There we go.
All right.
Ready?
Yes.
We've done it. Yes. Good morning, everyone. I'm Krista Marshall, and today I have with me Sam, Aaron, Laura, and Jordan, and we're going to be talking to you about our design process for the analysis and creation of a transfer station for urban composting in the city of Milwaukee. Today we're going to be talking to you about our problem background on a larger scale. We're going to bring it into the problem scope that we were presented in 508. We're going to talk to you about the design process that we went through, our cost analysis and evaluation of our project goal, and the closing thoughts. So on a larger scale, our problem dealt with the issue of food waste. We're going to bring it down locally on the next slides, but I'd like to present some things that we have to consider when addressing this issue. So globally, on average, we waste about 33% of the food that we produce, which is a big deal, and that translates to about $250 billion every year, which, if that doesn't economically make you a little bit uneasy, I'll talk about other consequences that we're facing. To bring it into a more understandable term, it's about 250 pounds per year per person. So every one of us, on average, is generating approximately that much food waste. The consequences are pretty extensive. Environmentally, that's about 33 billion tons of greenhouse gases. That ranges from the production side of it all the way to the consumer being thrown into the landfill. I presented an interesting photo. So about 25% of the total fresh water that we consume every year is for agriculture. We waste about 3 times the volume of Lake Geneva when we throw food in the landfill, which is, we've got Lake Geneva on the bottom right and Madison as a comparison for you on the top left. Socially, we've got a lot of issues of food insecurity around the world. So if we were able to bring down production and also maybe divert some of that food to people with food insecurity, we could make a big difference socially. And I'm going to pass it on to Laura for our project scope.
Okay, so we wanted to assess the feasibility of a system for the Milwaukee-based company Compost Crusader, who was our client. And we designed and analyzed the use of a transfer station for our project scope. And the transfer station is not a full composter. They use it as a place to store the food waste that's collected from homes, and then they can, Compost Crusader can pick it up incrementally so that they can save some trips out of the city to the composting site. And then we have here a picture on the left of the Compost Crusader truck and the pilot program that they're operating in Milwaukee. So here we have a picture of a few of our initial designs, and I'll run through those briefly and talk about why we didn't go with our initial designs. So the first one is the cylindrical drum, and that's on the right. Yes, right there. So the product enters the drum on one side, and the outer drum will spin, and the idea of the spinning is to increase aeration and mixing of the product, and the drum will also be slightly tilted downward so that the product will move through by force of gravity. And the second design on the top has 2 perforated filters, each with different size perforations. So the top filter has larger holes, and the smaller filter would have smaller holes. And then there would be fins around the outside of the device that would spin, which would incorporate the mixing and aeration action. And then at the bottom of that design was a small filter to capture any leachate from the composter. So at this point, our client expressed a desire to alter the direction of our project. And as you can see, the first 2 designs heavily emphasize mixing and aeration, both of which are crucial to complete composting. But discussions with our client revealed that a transfer station, like I mentioned earlier, would be just as valuable for her, if not more so, than a full composter, because a transfer station would save her time and money because she would have to take fewer trips out of the city, and it would spare her the added complexity of managing a start-to-finish compost system. So therefore, our final design features some machinery that's intended to expedite the composting process rather than perform the composting process, and Sam will talk.
So our final design concept is on the bottom right there, and we decided to go with a hopper-auger combination that would go into the dumpster. After our baseline decision, we thought this kind of looks like a gravity box design, as you would find on a farm that they use to transport their grains into other containers. So the auger takes the material from inside the hopper, and it will shoot it upwards into the dumpster with a 8 horsepower electric motor. And here we have some videos of our design. Why is it not playing?
Try the other one.
Okay, so as you can see here, there's the exploded view of the hopper and auger assembly. We have a canvas lid on top that we hope to be a magnetic cover to the top of the hopper to keep out pests and control odors. And here we have a top view of the hopper and dumpster. And inside the dumpster, you can see that it is perforated, and we think that a screen would work best because we plan on draining a lot of the water out of the compost since it is very water intensive. And quality compost has a optimized moisture content, but we are not too worried about that. We just do not want there to be extra water because one of the main concerns for them is the amount of water weight they have to deal with inside of their trucks. So here we have the exploded view of the dumpster, and we also have a lid on this. Also incorporated within the dumpster is this hydraulic press. We do this to compact the food waste and also squeeze out a little bit more of the water. And here we have the total final design. And we hope to make this out of higher chromium steel because that will prevent corrosion inside the hopper. Our design accounted for typical load sizes that Compost Crusader deals with during their routes. So the hopper and the dumpster will account for this both.
So the transfer station would essentially serve as a holding station in order to save money on transportation costs that are currently incurred by the company. These include fuel, maintenance, and labor costs that have to do with driving to and from the compost drop-off station twice per week. So we established this as the base case scenario and found that these costs total over $110,000 over a 5-year period. So we considered several different economic scenarios for this analysis. Using our economic model, the client can easily modify these in order to suit her future needs, as well as alter the parameters and assumptions that we used. These scenarios were evaluated on a few different financial metrics, including return on investment, payback, which tells us when our cash invested breaks even, and internal rate of return. All of these financial metrics are based on a break-even net present value that ranges between $1,000 and $50,000 depending on how much was invested in a given scenario. So the first scenario considered was that of an expanded business model. We leased space and we bought 5 new compactors. In order for this situation to be profitable, the company will have already had to be making 14 trips per week. So the second scenario we considered was also an expanded business model. We leased space, but we bought multiple used compactors. And this situation will be profitable if the company does 4 trips per week to the drop-off station, which is only 2 more than the current amount of trips per week. So next we removed the cost of the lease space by using Compost Crusader's existing warehouse, but kept the expanded business model with multiple used compactors. Scenario D involved no cost allocation. We also used the existing space, but we only used 1 compactor. And this would agree with the current amount of trips that Compost Crusader takes to the drop-off location. So both scenarios, C and D, realistically would make more economic sense than the first two, because these minimize the amount invested and maximize the internal rate of return over the 5-year project lifetime. So to sum up the cost-benefit analysis, most scenarios that were considered are economically infeasible for Compost Crusader's current business model, but this will be a viable option if it is operated out of the company's existing infrastructure.
All right, to recap, our client, Compost Crusader, needed a transfer station and on a separate piece of land to store, compact, and dewater food waste until enough is collected for a garbage truck. Unfortunately, the size of her current operation doesn't justify a transfer station in a leased building, as Erin showed in the cost analysis. We recommend our client either continue with her current operation or not have a transfer station, or operate the transfer station out of her existing building. We recommend continuing with her current operation with no transfer station, because the savings with the transfer station are very small and it would require a lot of effort. If Compost Crusader operations do expand by either the number of routes or the distance to the compost facility, we would recommend her revising our cost analysis spreadsheet, and a leased building could be profitable. And in conclusion, food waste is a very big issue in the world right now. Businesses like Compost Crusaders are combating this problem by trying to divert food waste from landfills. Their current operation requires too many trips to the composting facility in Caledonia, Wisconsin, just outside the city of Milwaukee. Our project goal was to design and analyze the use of a transfer station to maximize the efficiency and decrease cost. To meet our goal, we created a model of our final design using a CAD software and performed a cost analysis of the current operation and compared several scenarios. The cost analysis is available for our client to use and change if needed. Thank you for your time, and we're open to any questions. Cody?
So the question was about the specifications of the auger and whether or not we performed any physical tests. To the second question, we did not perform any physical tests. We did not buy any prototype materials. And for the first question, the original idea behind our auger is that it would double for use, in that it would also be able to kind of grind up some of the food pieces and make them smaller. As we moved through the project, we had another idea to use a screw press design in the auger, which would eliminate the need for a compressor in the dumpster, and then that would squeeze the water out in the auger itself. Unfortunately, we had gotten too far in the project to change it by that point, but that's something we could look into in the future.
That we were gonna.
Repeat the question.
So he's asking what we plan to do with the leachate coming from the compost. That is going to be up to Compost Crusader. We decided that that is outside the scope of our project. One thing we did talk about was talking with MMSD, the sanitary district in Milwaukee, and they might be able to just put it in the sewer, depending on the concentrations and so forth of the leachate.
So the question was how we determine the angles that would be in the gravity box portion of our design. And since we were trying to model our design off of buying things used, we created our model using the angles that we found for traditional gravity boxes that you could buy off of used farm sites.
Thank you. This group went over by 2.5 minutes, so I have to stop and keep moving also.